video, we're going to take a look at multiplication and 4 ways to multiply multi-digit numbers, and we'll be looking at the lattice, distributive, traditional algorithm, and estimation methods. And you can see there are a variety of standards that we're covering in this video. And we're going to be looking at this worksheet, and you go to worksheetsandwalkthroughs.com to print out a copy for yourself, and you can copy along as we move through it. And the directions are as follows. Multiply the following problem using the lattice, distributive, traditional algorithm, and estimation methods. And you can see the 4 different workspaces you have. So let's begin.
Okay, so there they are. Well, let's start off. Well, lattice is on top. Let's take a look at that first. We'll have to scroll down, give ourselves a little space to work with. I'll rewrite the problem. And it was 67 is one of the factors, with 52 being the other factor. So let's take a look. We've got 67 times 52. Now with lattice, this is something that was new for me. I never had seen this going through elementary school when I first learned multiplication. Thank you to all my teachers from elementary school. I used the traditional method and it worked just fine for me, but here's another way to do this. You can see there's a grid of 67 times 52, so it's a 2-digit by 2-digit number or problem. So your grid will be a 2 by 2 grid. And then we go a step further and we kind of divide these in half. You'll see why in a second. At the diagonal. So now I approach this by, well, I look at it and I see 67 on the top and I have 52 going down the side. So I'm going to start with that 5 here. I'm going to take the 5 and then multiply it by the 7 first. So I know that 5 times 7, or 7 times 5, is 35. Then I take a look at 5 times 6. All right, so that's 5 times 6 would be 30. Well, I'm done with that. Done with the 5, so I'm going to move on. And now I'm going to deal with the 2 in 52. You could start with the 6 in 67, in the tens place of 67, and multiply it by 5, then by 2, and work it that way. But I choose to do it this way. It's just a matter of personal preference. So here we go. We've got 2 times 7 would be 14. Hopefully you were thinking that too. 2 times 6 would be 12. I'll put that. Notice I'm separating the 1s and 10s as I write the product for each multiplication fact. So now what do? Well, what I'm thinking is I'm going to start down here with this 4. This 4 here. And I'm going to look kind of like in a diagonal direction. There's nothing in this same diagonal in here with the 4. Okay? So it's all by itself, so I'm just going to say, okay, 4 plus, well, there's nothing else to add to it. It would be 4. Now, we're going to move on to the next group. I've got the 2, the 1, the 5. I'm going to add those all together, so I have 5 plus 1 would be 6, plus 2, 7, 8. So I would have 8. 5 plus 1 is 6, 6 plus 2 is 8. Then I move on up here to the 3. You can see I'm going in this diagonal direction, plus the 0, plus the 1. 3 plus 0 is 3. 3 plus 1 is 4. And I'm left with this 3 up here. And nothing, again, like that 4 down below, there's nothing to add to it. So I go 3 plus 0 would just be 3. And you can see that my answer would be, or my product, if you want to use the correct mathematical term, would be right here. And to write it in a traditional way, we'd write 3, 4, 8, 4, and now we count over from, well, the decimal point would be there, because there's a decimal point in after the ones place in every number, really. So we've got to count over 3 spaces and put my comma in there. We've got 3,484 as the product. Okay, so that was the lattice method. Lattice method. Let's move on to the traditional. Actually, let's do distributive. We'll do the distributive property, still using the same factors. And if it all checks out, you're still getting the same answer, the same product. So now, I'm going to rewrite this math problem. 67 times 52. And then the distributive property we will use to break this number down and rewrite it. I like to think, okay, well, I've got a 2-digit number by a 2-digit number. It would be 2 times 2 is 4. So I always like to write down the steps on the side here. 1, 2, 3, 4 steps for a 2-by-2 problem. Okay. Well, the first step is, well, I'm going to take it like the traditional method would. And I'm going to multiply by this 2 first of all. Okay. See if my highlighter will show up here. Oh, we don't want that. Let's take a look. We've got 2 times 7. They're both in the ones place, so I'm simply going to write 2 times 7 equals, leave it like that for now. Then I'm going to move on. Now I'll work with the same 2, but like in the traditional method, I'm going to multiply 2 times 6. Well, the 6 is in the tens place, so it's actually 2, because 2 is in the ones place, times 6 tens, or 60. That's the second step. Then I'm going to bounce over here to, since I've worked with the 2 in the ones place of 52, and I've multiplied it by the 7 in the ones place and the 6 in the tens place. I'm done with that. That looks a little messy for you. Let me just get rid of that. There we go. So now I'm going to multiply the 5 in 52, well, by the 7 in the ones place of 67. So I'm going in that same type of pattern. Not sure if this will show up so well. Oh, look at that. Okay, I'm going to multiply the 5 times the 7. Again, the 5 is in the tens place, so that will be worth 5 tens, or 50, times 7 in the ones place. And then, for the last part of this, I'm going to multiply the 5 in the tens place of 52 times the 6 in the tens place of 67. So when I write it down, I've got to remember that it's 5 tens again, so that'd be 50, times the 6 tens of 67. 6 is in the tens place, it'd be worth 60. And oh, we gotta put our equal sign there. So now I've got all the multiplication sentences I need to solve for. Now I've got 2 times 7. Well, I know that would be 14. 2 times 60. Might not know that one so quickly. Well, it's not as hard as it appears. I'm going to rewrite it over here. I've got 60 times 2, or 2 times 60. Be the same thing. We've got The basic fact of 6 times 2 would be 12. And I have this 0 left over because I'm really multiplying by tens. So I need to tack that 0 back on at the end to come up with 60 times 2 equals 120. 120. Okay. I want to put it underneath this 14. So I've got to line up the places. And you'll see why in just a couple steps. All right. So I've solved for that. Now step 3, 50 times 7. Again, I'll show my work over here. 50 times 7 equals, the basic fact would be 5 times 7 is 35. Multiplying by those tens, so I tack that 0 back on. And I have 350. Here it is, 350. And last but not least, we've got 50 times 60. Oh, goodness. 50 times 60. 50 times 60 equals, again, I like to go back to that basic fact. That's why it's so important to know those basic facts. We've got 5 times 6. Well, I know that is 30. Hopefully, following along with me, you're thinking the same thing along the same lines. We've got 50 times 60 is 30, and we have not dealt with these two zeros because we're multiplying by 2. Okay, both numbers are in the tens place, the 5 and the 6. So you've got to tack on those 2 zeros, leaving us with 3,000. That's just a little shortcut. You can go through the traditional method of multiplying there to get it, or the lattice method, whatever you prefer. But I'm trying to show a completely different method called the distributive property. They're all interrelated, but I wanted to show them separately. So now I've got my work crowding here, so I'm going to try to move this a little bit. Fortunately, with these tools, I can do this. Slide that over just a little bit because I've got to make room for the thousands place when I write this in here. Why? Well, I'll show you in just a second. We've taken apart the numbers in 67 and 52 to multiply them. And now we really have to put them back together. And to do that, we're going to add all of these products together. Starting with the ones place, we've got 4 plus 0 plus 0 plus 0 equals 4. 1 plus 2 is 3. 3 plus 5 is 8 plus 0, still 8. Now we've got the 1 and the 3 in the hundreds places here, in the hundreds column. 3 plus 1 is 4. And we just have this 3 left over here in the thousands place, so we'll just bring that right back down here. There's nothing to add to it. So let's check to see if our product here matches the product from up above. We've got 3,484. Did we have the same thing in the lattice method? 3,484. Yes, working so far. Now, for all you parents at home, you probably used this method just like I did when I was learning how to multiply multiple digit numbers. We'll start with the same one. We had 67 times 52. And we started with the ones place. The 2 times 7 would be 14. Here, the one up top. 2 times 6 is 12. 12 plus 1 is 13. We have to carry that 1 over there. And it drops right down. Then we have to work with this 5 here. Let's use a different color for this. We're working with this 5. 5 times 7 is 35. So we're starting with the 5, so I'm going to start to write my products right under there. 5 times 7 is 35, so the 3 goes up top. 5 times 6 is 30. 30 plus 3 is 33. And then we add those all together, and we get, well, some people, I should stop and say, some people like to put a placeholder 0 in here. And that's just fine. You can do that. Kind of keep track of where you need to put your products. 4 plus 0 is 4. 3 plus 5 is 8. And 1 plus 3 is 4. 3 still all alone by itself. Right there. Now let's check. Looks like we've got the same answer. The same product. 3,484. 3,484. 3,484. Now what's left? Estimation. And you can use these interchangeably to check to make sure you have the correct calculation. So now we are going to rewrite the problem once again. So we have 67 times 52. And this time through, we're going to do the estimation method. So, let's see, 67. Well, if I think about it, 67 is between 60, one benchmark number on one side, and 70 on the other side. Well, in this case, I'm going to be rounding. Okay, rounding is a form of estimating. So I'm looking at the 6, and the 7 next door in the ones place tells me if I'm closer to the next group of 10s, which would be 70, or the previous benchmark number, which would be 60. So the 7, if a number is 5 through 9, I kind of round it up that number line. So the 67 would round up to 70. So over here, I'm going to write 70. If you follow the arrow, we see 67 rounds to 70. And now we have to take care of the 52. 52 rounds to, well, let's think of it the same way we did with the 67. We've got 52. And let's see, 52, it's between, well, I'm thinking about the tens place here. So 52 is between 50 and 60. You might automatically see how 52 would be closer to 50. And that's fine, you can do it that way. But if you want to break down the numbers by rounding, we can do that as well. Okay, the place we're looking at is underlined, the tens place, and the ones place tells us whether we should round up or round down. If a number is 0 through 4, round it down to the benchmark number before. So that's the case, isn't it? 2, yep, 0 through 4, yes. So clearly, 52 would round to 50 to the nearest 10. So now we're going to rewrite that over here. I think I'll move this rounding bit out of the way a little bit. Slide it over there. And now we've got 52 rounds to 50. Some people call this front-end estimation, I believe. So now we're going to multiply these two together. We're going to multiply 70 times 50. Well, we could do the traditional method to solve that. Or, like I was showing you earlier, we could rewrite this as 70 times 50 equals, I'll take a look at my basic fact here. I've got 7 times 5. Well, that's a lot easier to work with. So 7 times 5 is 35. And both numbers were in the tens place, so we've got 2 zeros to tack on. It would be 3,500. Now, you'll notice that 3,500 is not exactly the same as 3,484. Does it mean it's wrong? No, it does not. It's estimating. And estimating is not an exact science. So that's why when you come across it in, say, a word problem, you might see the word about how many, or estimate. They might plainly just put it right out there for you. So there you have it. It is very close in the whole scheme of things. 3,500 is very close to 3,484. So you know that would be a good estimate. It would be helpful to use estimation to check your multiplication if you're trying to do a quick check, but you can use any of the other methods. So again, we had a lattice, the distributive property method, a traditional algorithm, followed by estimation. And there you have 4 different ways to multiply.